Yeast, a common ingredient in many dough recipes, especially bread dough. This living fungi that occurs everywhere in our natural world has been industrialized for baking purposes. This is because of the awesome biochemistry that occurs when we introduce yeast to the other ingredients in the dough. When introduced to hydrated flour, our yeast actually start to feed on the glucose that the flour consists of. While usually present in long, unbroken chains, glucose can actually be broken down by amylases, which are enzymes that naturally occur in flour. This is helpful for the yeast because then they can digest the glucose and use it for glycolysis, which is the metabolic reaction that occurs in order to create ATP, a molecule that is essential to powering all of life's functions. While the end product of yeast energy creation process is actually a molecule called ethanol, what we're more concerned with here is a byproduct of the reaction, gaseous carbon dioxide. This carbon dioxide gets trapped in our dough because of two proteins, glutenin and gliadin, that naturally occur in flour. These proteins form bonds and create a vast network that is both strong and elastic. So when the carbon dioxide gets released and stays in the dough, it causes the gluten network to inflate. This is why our bread rises and forms bubbles when we leave it out overnight. To get a true grasp on why yeast is releasing this carbon dioxide for us, we need to understand the type of respiration it's performing, called fermentation. This is an anaerobic respiration, meaning it occurs without oxygen. In the typical aerobic respiration we may be a bit more familiar with, NADH is converted back into its original form of NAD+ by oxygen. NAD+ is essential in the complex ATP synthesis process because it carries electrons and it accepts an hydrogen ion. This allows for glucose to be broken down into the pyruvate molecule, which is how energy is created. However, in our bread dough, there's no oxygen to take the hydrogen ion back from the NADH so that it can be reused as NAD+. So, our yeast has to turn to an alternate method. Instead, it takes a carboxyl group off of the pyruvate molecule. This is seen as the release of the carbon dioxide gas in our dough, and it's the simplest step that explains why we use yeast in our recipes. From here, an acetaldehyde molecule remains. This molecule is what takes the hydrogen ion back from the NADH so that the ATP creation process can be continuous. This is how yeast sustains its life without oxygen. It's crazy to think about how we have harnessed this biochemical process for our own use in bread making. Next time you're using yeast in a recipe, I hope you remember the important role it plays, down to the molecular level. Thanks for watching.